Okay, so let's talk about how to define Python functions. So what exactly is a function? And what we have is, like I said, we've used them. Things like length, things like range, those are functions. You give it some inputs, length of what, right? And then it returns you some output. Now, functions are absolutely critical in programming. They're kind of the foundational piece. And the reason for that, well, it's really twofold. Number one, it helps you to reuse code. So there's some code that actually counts the number of elements of a list or of a string and tells you, well, the string has so many letters in it. That's the length, right? That exists. Somebody has already written that. I can use that code. You can use that code. All of us can use that code. We don't have to write it. We don't have to rewrite it, which means that we could introduce bugs. Maybe we wouldn't do it very efficiently. All sorts of things happen. We don't have to do that. We just reuse it in lots of different situations. This is good, okay? Now, the other reason that it's good is simply because of abstraction. And when you're dealing with code, you know, maybe you have a program that's, say, 100 lines long. That may feel like a really big program right now, okay? You know, that's huge. Well, it's really tough to think of all those 100 lines at the same time. The way that we write large programs is really not by writing lots of lines, it's by hiding lots of lines, so that at any one time you're focusing only on what you see on your screen and not on the entirety of the program. The rest of it is kind of abstracted away. We don't have to see it right now, basically by hiding it behind functions, okay? So we use functions to help us scale our programs from a tiny little program to a bigger program that does something more useful, okay? So now let's, what we're gonna do is we're gonna start writing our own, so let's do that. Now, here's how you write functions in Python. The keyword here is def, def for define, okay? And so you have the name of the function. This is the function called sum up to, right? Then we have a parentheses, and what we list after that is the arguments to the function. So sum up to needs something to be given to it. It needs n, right? So that we can get the sum up to n. And here I'm using it, so I have sum up to 100. Sum up to 1,000, okay? So that's how we use the function after we write it, okay? So you have to give the value of n. Now, notice right here, something cool that's happening, and that's the code reuse, right? We're actually calling this function twice in different places to get the sum up to 100 and sum up to 1,000. You could do it for anything that you needed to. Okay, now here is our definition. So after you say def, the name of the function, parentheses, the names of the arguments, close parentheses, and then colon, right? Remember, this is Python. You always have a colon at the end, right? Then you indent, and what goes underneath that is the body of the function, or the actual function definition. So how do I compute the sum of all the numbers up to n? Well, we've done code like that already, right? So we start with a variable. We say, well, start at 0, right? Because I'm adding things up. So start at 0, and then we hop in a loop. And here's our loop for I in range 1 to n plus 1. So we go 1, 2, 3, all the way up to n, not including n plus 1. Sum is equal to sum plus I every time inside the loop. So we start at 0, then we add 1, then we add 2, then we add 3, all the way up to n. And then at the end, we return sum. Return means this is the value of the function. So when somebody says sum 100 equals sum up to, that's what sum 100 is going to get. It'll get that value of n, okay? So that's how this function works. That's it, okay? That's how you define your own functions. Now, like I said, here's code reuse, right? We're actually calling this function from multiple places. And here is abstraction. Now, when you'll take some math classes, at some point somebody will tell you that if you actually add up the numbers 1, 2, 3, 4 up to n, that's actually always the value of n times n plus 1 divided by 2. Okay, you can try it if you don't believe me, but I don't recommend trying it with 100. Try it with like 4 or 5. Okay, and you'll see that actually works. So sum up to n is the same function, right? But now I'm going to implement it. I'm actually going to write the code. Instead of going on a loop and adding 1, 2, 3 up to n, I'm simply going to return n times n plus 1 divided by 2. What is the great thing about that? Well, you know, this is a faster version of sum up to n. It still returns the same value, so we can use it from anywhere like we did before. We don't have to care about the fact that it's faster. We just get to take advantage of that. It just happens. That's awesome, okay? So that's the way that that works for us. Okay. Now, I got to clear something up. Here are two different functions, sum up to n and product up to n. As you see, the functions are almost identical, right? For products, we don't want to initialize at 0 because then 0 times stays always at 0. We'll initialize it at 1. Okay, so that's why product equals 1. And then we're not adding we're multiplying. Prod times I, not prod plus I. Other than that, it's the exact same function. Okay, and again, this is part of what I want you to get. This is, you know, those little patterns, right? So, oh, I want to go through all the elements from 1 to n. What do? Hop in a loop. Okay, all right. So here we have sum up to n. I want you to realize that n is kind of like a variable, right? And so I'm using n here, right? N here. Interesting, right? Those variables have the same name. Is that the same n, right? Are they different versions of n? Here we have I, right? Here we have I. So, you know, we're multiplying by, we're adding by. Is that the same I? Is that a different I? Okay, so let me just get rid of the mystery. It is a totally different I, okay? And that's what you want, okay? You want the values of the functions, the variables in the functions to be different, to be local to the function, okay? And that's the way Python works. So if you have a function inside your code, right, then it will just simply be special to that function. Okay, if you define a variable in there, I kind of like to think of it as the variable is sum up to .i, right? You know, it's kind of scoped in a sense by sum up to. Now there is an exception, and I'll warn you about this because you might run into this in your code. If you actually define I before you get to the function, like I is equal to 3, okay, then it will say, oh, this must be the same I that's outside. And so it'll think that. That's a mistake. That's a bug that people make. My recommendation is simply to write all your code inside a function, right? You know, we haven't been doing that because I haven't been writing functions, but from now on, go ahead and do that. Always write your code inside a function and then just call it right at the end so that it actually gets executed. Okay. All right. So that's the idea. These are different variables. Now let's make that even clearer. Okay. Look at this incredible thing. This adds the products. Sorry about that. This adds the products up to n, right? So the products up to n, 1 would be 1, 2 is 2, for the third one is 6, 2 times 3 is 6, the one after that is 24, and so on. These are n factorial if you've seen that notation. And then it just adds the value of n factorial, or the products up to n. Okay, so here is a variable I, here is another variable I. If that was the same variable, then this code would never work because here I am trying to find the products up to I, right? And that would change the value of I as he was doing that. So this would be a disaster. Again, that's just not the way it works. Thank God, okay? Even though two variables can have the same name, if they're in different functions and they're only in those functions, right? Then they're totally different variables, right? I might just want to point out, of course they are, they have to be, because if they weren't, something terrible could happen, and that is that you call the function length, for example. Who knows what length does? Who knows what variables it defines? How would you know to stay away from the variables that len uses? You wouldn't. So that would be bad. Luckily, Python doesn't make that mistake. Okay. All right. One last thing I want to tell you about defining functions, and that is that some functions can actually have different kinds of arguments. So, for example, we've seen before. Oops, I did it again. We've seen before range. And you can say range of 5. And what that returns is something that looks like 0, 1, 2, 3, 4. Right? But we can also say range of 1, 10. Okay? And that actually returns something that looks like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? The crazy thing is that you can either call it with one argument or with two arguments. Right? How's that supposed to work? Well, Python actually lets you do that. And you can see there's a pretty good reason. I mean, this is a great reason why you might want to allow that. Most of the times you're happy to go from 0 up to n minus 1. Sometimes you want to be more precise on where you want to start. So that's why there's two versions of range, right? So here I try to give you kind of an example of another function that could have two arguments. This is the function root. It's like taking the square root or the cube root or the nth root, right? This is the root of something. You give x, that is what you want to take the root of, and then you can give a base that says, well, what kind of root do you want? Most of the time, I'm going to just say that, most of the time you want a square root, right? So why force you to say 2 every time? Does it mean square root? Just call it root, pass in the number, and it returns the square root of that number, okay? Sometimes you actually do want the cubic root or the 5th root or the 10th root or whatever. So here is, for example, the square root of 10, right? That is root 10. There's no need to say, oh, base is 2. This is the cube root of 10. So what we do is put in the 10, and then we say, oh, comma, base equal to 3. base, that's the name of that parameter. And so we just give the name and say equal, right? So base is going to be 3, not whatever that value you'll use, if I don't tell you. I wanted you to see that you can actually also give names to the normal parameters that you do have to provide every time. There's nothing keeping you from saying x equals 5. It's called x, you can say x equals 5, and then it just passes that value. I actually like doing this as opposed to this. The mixture sometimes makes me uncomfortable, so I like being explicit, what's what. But Python will handle it either way, okay? I guess I didn't give you an example, but you can also say root 10 comma 3, okay, like this. Root 10 comma 3, and it just knows the first argument, which is x, is 10. The second argument, that happens to be the base now, is 3. So you don't actually have to provide the name, just like in range, see? You know, we just say 1 comma 10. So whatever actually works for your particular case is good.